Another example for class 22 is this one right here out of Borgnacki, problem 6.9. It says carbon dioxide is compressed to a smaller volume in a polytropic process where the exponent is 1.4. How do the properties, internal energy, enthalpy, entropy, pressure, and temperature change? Do they go up, down, or are they constant? This is a head scratcher because it's not really dealing with just plugging and chugging equations. So let's see if we can try to figure it out. Well, first thing, let's look up in table A5 and find out what K is equal to. It's 1.289. Something we note right here is that N is greater than K, right? So when it goes to looking at curves, looking at the motion that might get made, I gotta try to figure out where these, right? Remember that we, when looking at these diagrams right here in figure 610, we can kind of give ourselves an idea of what side we are on these by comparing N and K. N and K, when they equal to each other, means that we're isentropic. So now we got to try to decide, is it going to be increasing or decreasing in entropy? Well, we could ask that right away. So we just said that N was greater than K. So N greater than K is this one. So it looks to me like we're going to be increasing our entropy. Is that true? Okay, so yeah. So we don't have to go in the same order as we went here. I already jumped the gun. So I'll go S is going to go up. It's going to increase, right? And why is that? Because N is greater than K, and say see figure 610, right? So we're communicating, right? So that's why, don't just write yes. Explain why yes. Don't just say, yeah, it's going up. No. Be a thinker. And let's see, other things I want to do. Let's see, maybe go about temperature. Why? Well, no, let me go to pressure first. Pressure, this is kind of like just sort of duh. It's going to go up. Why? Because it's compressed. Right? Because compressed. Things go up. Pressure goes up when it gets compressed. Also, yeah, so I'm trying to think. I said something over here goes to the left. But let's say, take a look at the, I also, okay. You also say that T, what is T going to do? Well, it's probably going to go up. This PV equals RT, right, kind of thing. But this helps us decide which motion is taking place. So the T is up. I'm saying it's because we're increasing, right? We're coming from up here to up here, right? So we're going to be moving from along this curve and going up. So it's going up as well, right? It's not an isothermal process. If N was equal to 1, then it'd be isothermal, but it's not. So therefore, you could also say because N does not equal to 1, N is greater than K. And N is greater than K, right? Because it could be less than, N could be less than K, and temperature could still be going up, right? So it's not solely because of this right here. And then U is going to go up because delta U is equal to CV delta T, right? So if T is going up, U is going up. And then you can also say the same thing for H, up, because, and this is an approximation, but still, even if it's just an approximation, it's still going to be held true, that the enthalpy changes with the temperature, right? So the temperature does often controls a lot of things. So it's whether the temperature goes up because of the pressure, but I think it's safe to say that it does go up. And if we were making people were forcing us for whatever reason to do a TS diagram and a PV diagram onto the thing, you could say, well, you're compressing, so you must start out at 1 right here and go in that direction, and we're going upwards to there to 2. But how are we going? Well, we're going to be, because our n is greater than k, we're going to be below this right here. So we're going to draw right here and say that this is isentropic. And here's one right here. We're going to go, we're going to start like maybe right here at a temperature 1, and we're going to come upwards as we're going to go to the right, because we're saying that we're increasing, and as this would be straight, this would be isentropic, but we're going to come up this direction right here. So we're going to come up at some amount of curvature to go to 2. Right, so because we're going to go up right here because n is greater than k, whereas we would be coming this way and going in the opposite direction if n were less than k. But notably, that temperature is still going upwards. All right, so that was problem 6-9, just conceptual, really.